students, welcome back to the new module of our chapter called Magnetism. In this particular module, we'll be learning multiple choice questions which are based on magnetization and magnetic intensity. Now students, we have already learned this concept in the previous modules, right? So let us start with the first question, which says a magnetic intensity of 360 ampere meter inverse produces a flux density of B is equal to 0.6 Tesla in a ferromagnetic material. What is its permeability in Tesla meter ampere inverse? And the options are option A 1 by 300, option B 300, option C 1 by 600, and option D is 600. Now student, from this particular question we can say we are provided with magnetic intensity, which is given by symbol capital H, right? At the same time, we are also provided with flux density, which is given by symbol B. So we are provided with two things, B and H. And what we need to find? We need to find permeability in this case, and it is given by symbol mu. So we need to have a relation between B, mu and H. Do we know such kind of relation? Yes. And the relation is B is equal to mu into H, where B is flux density, mu is permeability, and H is magnetic intensity. Now after rearranging, I'll get mu is equal to B upon H. Now I know value of B. What is value of B? It is 0.6 Tesla. I also know value of H. What is value of H? It is 360, right? So if I put these two values, what we'll get? We'll get 0.6 upon 360. So after calculating, I'll get final answer as 1 by 600 into Tesla upon ampere per meter, right? So if I rearrange it, I'll get mu is equal to 1 by 600 Tesla ampere inverse into meter, right? So which is the correct answer? In this case, option C is the correct answer, right? Now let us move further on second multiple choice question. It says the relative permeability of iron is 2000. What is its absolute permeability in SI units? And the options are 4 pi into 10 raised to power minus 5, option B 8 pi into 10 raised to power minus 7, option C 8 pi into 10 raised to power minus 4, and the last option, that is option D, 2000 upon 4 pi into 10 raised to power minus 7. Now students, from this MCQ you can gauge we are provided with relative permeability, which is given by symbol mu r. So we are having mu r, and what we need to find? We need to find absolute permeability, which is given by symbol mu. So we need to have a relation between mu and mu r. Do we know such kind of relation? Yes, and the relation is absolute permeability mu, it is equal to permeability of free space, which is mu naught, multiplied by relative permeability, which is mu r. So what will I get? I get mu is equal to mu naught into mu r. Now we know value of mu r. What is value of mu r? The value of mu r is 2000. At the same time, we also know value of mu naught. What is value of mu naught? It is 4 pi into 10 raised to power minus 7. So what will I get? I'll get mu is equal to 4 pi into 10 raised to power minus 7 into 2000. So if I calculate it further, what will I get? I'll get mu is equal to 8 pi into 10 raised to power minus 4. So which is the correct answer? In this case, the correct answer is option C. That is 8 pi into 10 raised to power minus 4, right? So let us move towards third MCQ. It says a domain in a ferromagnetic material is in the form of a cube of side length 1 micrometer. The dipole moment of the domain when all the dipoles get perfectly aligned is 5 into 10 raised to power minus 12 ampere meter square. What is the intensity of magnetization of the domain in this situation? And the options are option A 4 into 10 raised to power 5 ampere per meter, option B says 5 into 10 raised to power 5 ampere per meter, option C 6 into 10 raised to power 6 ampere per meter, and last option 5 into 10 raised to power 6 ampere per meter. Now students, in this case we need to find intensity of magnetization or magnetization. Now we know formula for magnetization. It is given by net magnetic moment per unit volume. So firstly we need to calculate the volume of the cube, right? So for calculating volume we need length, and the value of length is 1 micrometer. So it can be written as 1 into 10 raised to power minus 6 meter. Now from this length we can calculate volume. What is the volume of cube? Volume of cube is given by L cube. So it will become 10 raised to power minus 6 cube, which is equal to 10 raised to power minus 18 meter cube, right? So we got the volume. Now we know formula for magnetization. The formula for intensity of magnetization is net magnetic moment per unit volume, that is M by V. And we know value of net magnetic moment. What is the value? The value is 5 into 10 raised to power minus 12 ampere meter square. And we have calculated value of volume. What is it? It is 10 raised to power minus 18 meter cube. So if I place these values, what will I get? I'll get 5 into 10 raised to power minus 12 upon 10 raised to power minus 18 ampere meter square upon meter cube. So after calculating, I'll get the final answer as 5 into 10 raised to power 6 ampere per meter. And this is nothing but the value of intensity of magnetization. So which is the correct answer? In this case, option D is the correct answer. So students, in this particular module, we have learned multiple choice questions which were based on concept called as magnetic intensity and magnetization. In the forthcoming module, we'll be learning several interesting MCQs. Till then, keep learning.